absolute loader demands the information from assembler in a text card and transfer card format, right? If you're looking at BSS loader, it demands the information from assembler in the form of transfer vector, object code, relocation bits, and the length of both the transfer vector and object code. In the same way, direct linking loader demands output in a different format. जो भी output assembler का है, that will become an input to this loader, right? So assembler need to be changed according to the need of these loaders. Accordingly, you have to use the particular assemblers. So what exactly needed by direct linking loader? So basically your assembler will generate the output for direct linking loader in the form of 4 different cards. So that cards will help us for linking, loading, actual data and the transfer purpose. So purpose is same, but way of providing information, way of maintaining the cards will be different here. So very first information required by this loader is length of each segment. If you are using multiple segments in a co-program, so length of the segment is expected. Then list of all the symbols which are defined in current segment but utilized in some other segments. So all such a symbols are coming with entry keyword. You are well aware with this entry and extern keyword now, subroutine linkage. So if your symbol defined in current program and used somewhere else, so list out them with entry keyword. Vice versa, if your symbol used in current program but defined in some other declaration other program में, then provide the list of such a symbols with a extern keyword. So you need a length of segment, list of entry symbol, list of extern symbol provided by assembler. Then the information about address constant, that is a relocation information. So all the information about address dependent constant need to be provided. So that information like location of that particular constant in the segment. Then description about how to update that, whether to add a base address, whether to subtract a base address or keep it neutral, kind of. And then target code, that is an object code generated by your assembler. So this is what information we require from the assembler. And this information is maintained in 4 different cards. So again, 4 different card formats are coming to you. And once you remember all these card formats, now you will be able to discuss all these loaders very well. Okay, so just remember the name of the cards and particular loaders. So same information is provided in 4 different cards for this loader. So first card is your ESD card, second is text card, RLD card and N card. So ESD card is your external symbol dictionary. So it's like your dictionary. What the dictionary says, some words are there and their meaning, right? So same your external symbol dictionary is doing. It will be having all the external symbol entries along with their meaning, whether it is a local definition or local variable, whether it is a segment name or it is an external symbolic routine. So such a information will be maintained on your external symbol dictionary, that is ESD card. Second is a text card. Text card will hold your actual object code. So it will be having its location counter or relative address along with a object code, translated object code. Then third card is RLD card, relocation and linkage directory. Okay, RLD stands for relocation and linkage directory. So relocation and linkage means if any address dependent constant is there, on which symbol it is dependent, how it need to be relocated by adding, subtracting the value, and where to link it. So that information is maintained on your RLD card. I'll give this is just an abstract view. I'll give each card along with its detailed information in next few slides. And the last card is N. N card will act as a transfer card. If you remember your absolute loader transfer card. So role of transfer card is jump to the location where you can start the execution. So same job is done by your N card. It will be having address of first instruction of your program from where execution will begin. So as soon as you get the N card, control will jump to that location. That's it. Okay. So your direct linking loader or DLL loader requires input in the form of these four cards. These four cards are keeping information about length of the segment, external entry symbols, total size of your object code, and the starting address of your object code. So let's see all these cards one by one in detail. So very first is ESD card, external symbol dictionary. So it contains information about all the symbols. Okay, so all symbols which are defined in current segment but used somewhere else, that is entry. All the symbol coming with entry keyword. All the symbols used in current program but defined somewhere else. So external list. So all the symbol coming with entry and external keyword will be maintained on ESD card with additional information. Okay, and what's the format? So it's like a table. This card is maintained as a table which will be having around 5 to 6 fields. So first field of this card is maintaining source statement number. Based on your program source statement number, this source statement number is for our reference. We are maintaining for our reference. Then second is actual symbol name. Third field shows type of a symbol. So type of a symbol is like whether it is a local symbol coming with entry keyword, external symbol coming with external keyword, or it is a segment name coming with a start pseudocode. So likewise list is maintained and type will be maintained. Then you have to allocate unique identifiers to each of these symbols. So ID fourth field maintains a unique identifier 1, 2, 3 onwards. Okay, it should not be redundant. And then fifth field is address location counter value, relative location value for that symbol when you translate it. And the last field is length of a segment. So in this way, ESD card maintains information about all this. Now for each type of symbol, values of length and relative address may vary. Okay, so I'll tell you in detail where how it changes. Like for segment definition, you will be having length, but you can't have length of rest of two types of symbol. So I'll show you all those things detail one by one, and then I'll explain with one example. Don't worry. So first of all, try to understand what we are maintaining in these tables. So sequence number, as you know, it's just a statement number coming from your input file. Then name of a symbol along with a type. So remember, you have a three different types for each symbol. Possible type is either of. There are total three different types for a symbol. It may be a external symbol, external reference. So symbol type you can set it as a ER, external reference. If you keep it LD, it will be a local definition. And if you keep it SD, it will be a segment definition. Now, how you will distinguish whether it is ER, LD or SD? So if your symbol coming with start pseudocode, then its type will be a segment definition because वो segment का नाम होता है, procedure का नाम होता है. So your type will be segment definition SD. If your symbol is coming with external pseudocode, its type will be external reference ER. If your symbol is coming with entry pseudocode, then your type will be local definition. Okay. So type of a symbol can be local definition, external reference, or segment definition. Based on this type, rest of the field will be updated. So please pay attention over here. So as I said, entry symbols coming with type LD, external symbol coming with type ER, and the stamp symbol symbol coming with start pseudocode is a segment name. So keep its type as SD. So for each program, there will be only one segment definition entry for each program. Per program, you will be having only one SD entry. Multiple LD and ER entries are possible. Then relative location is the address of or the value of location counter where that particular symbol found. So for segment definition, you will be having a value. For local definition, you will be having a value. But your external reference is not known to you yet. So it will keep it as blank. So आपका relative location ER के लिए blank रहेगा. Rest of the two types can have their values. And then length. So length will be a length of a symbol. So only segment definition, symbol with a type segment definition will have a length. Rest all will not have any length field. So for external reference and local definition, length will be empty or blank. Only for SD, it will be updated. So this you have to remember कि कौन से symbol type के लिए values set होने वाले. So for ER, no relative address. For LD and ER, no length field is set. It will be blank. And segment definition will have the length of that program. Program का पूरा length ही आपके segment definition का length होगा. So if you put this information in this format, you'll be able to match with it. So I'll take one example. So you will be able to see the entries in this fields. Fine. After ESD card, next card is text card. Text card is very simple to remember because it is having object code along with its relative addresses. So it will be having main two fields, but I have added a source statement number for our reference. So source statement number from your input file, a relative address is your location counter value, and the object code is your translated code by a assembler. So in this way, you will be having these three fields. Okay. So I'll take one example and then you'll be able to see the text card, actual text card, how it looks like. Then third card is RLD card. So for DL, direct linking loader, ESD card entry and RLD card entry. These two entries are a bit difficult to maintain. Once you make a good practice, you will be able to do that. Okay, don't worry about it. But you need a good practice for it. Then third card is RLD card, relocation and linkage directory. So it will be having its own format. So this card contains the information about the program address dependent constants. There are some address location in your program which are depends on some other addresses. So their entries, relocation information is required. So that entries are maintained on this card. Okay. So it also specifies, means it is not maintaining who is dependent on which symbol. Additionally, it maintains the information how you will adjust that location. Relocation कैसे करने वाले हो by addition or subtraction of a base addresses. So that updated info, how to update info is also available. So how your card will look like. So this is what your card is. So around 5 to 6 fields are maintained for RLD card. So again, if you look at the first field, this field is your source statement number coming from your input file. And then please look at here second field, ESD ID. If you remember, on ESD card, we have assigned unique identifier to each symbol, right? So that identifier he should be kept here if symbol name is same. So third field में अगर आपका symbol name आ रहा है जो ESD card पे है, so pick the unique ID and add it here in the second field here. Okay. And then flag value. Flag value will be either plus or minus. So this will inform whether particular symbol is updated or relocated by adding the base value or by subtracting the base value or do nothing. Okay. So usually we will add the addresses only for some constant field or subtraction is specifically mentioned in your calculations, then it will be subtracted. Then length. And so length field is giving you the length of that particular symbol and the relative location is the location of that symbol on a card. So same info is available here on next slide for your reference. So RLD card is filled relative locations. So it contains the address of that constant within the segment, or you can say location counter value. Symbol is the name of a symbol. Now please look at here. Relative location is the location which we are going to adjust. वो जो location है वो relocate करना है. That is given by relative location. And the symbol is the name of symbol on which your address is dependent. Okay. So ये जो relative location आप update करने वाले हो, whose address will be adjusted with the value of the given symbol. Okay. So please try to understand. Symbol is the name of a symbol whose address we are going to use to update all these address dependent constants whose address is given by your relative locations. And the flag value will tell whether your relative location and the symbol values are added, subtracted, or what else. So how to adjust? So it can be either plus or minus. based on your situation. And the last one is length field. So length field is the address of that constant value, whatever relative address is you're going to update. And as you know, relocating loaders, all the address field or instruction fields are of 4 bytes. So length will be of 4 byte here. Okay. And then last card is end card. So end card is very simple. It indicates the end of a program reached. As well, it maintains the starting address of your first instruction from where execution will start. And this is maintained for only main program, not for subroutines where main is not exist. So in this way, your RLD card, ESD card, end cards are maintained. Formats we have discussed. Do you have any questions regarding formats? Otherwise, I'll go ahead for example. If you have understood all 4 tables or all 4 cards, then only we can move towards the example. And then I'll show you how the entries will be updated in that tables. So let me know if you have any questions related to your cards. What the information maintained on those cards. Okay, no questions from your side. So hopefully your doubts will be cleared when we will go ahead with the example. So again, for example, you have to assume a sample assembly code and we will translate it. And based on that translated data, we will keep the information in all 4 tables. Okay. So here you need to keep little bit patience. So assume your example is source code, assembly code is given here. John start. So start pseudocode is coming with a label John, and this will be a segment name. Operand field is not exist, so your location counter will be initialized to 0. Okay. And then list of symbols which are defined in current program but used somewhere else. So result is a variable coming with a entry pseudocode. Means what? This symbol declaration you will found in the same program, but it can be used somewhere else. That's why entry keyword list is maintained. The next one, symbol sum. Sum is used here in current program. So you may jump to the sum where sum is written in some other location. It will be a procedure defined somewhere else. Then ST. ST is a storage. So store the value of save variable in a register 14. Load the value of pointer in a register 1. Load the value of address sum in a register 15. BALR is a branch instruction, branch and linkage register. So branch to the address given by register 15, okay, and return address given in register 14. Then again store the content of register 1 to the variable result. Then load the content of save in a 14th register again. Branch to the location given by 14th location, 14th register, branch to that location 14. Means 14 will be hold the address of some in location. And then 7th statement is giving variable declaration. So variable table is declared here, and it is a table of, or you can say array of 5 elements. See here, 1, 7, 9, all are comma separated values. The next pointer is a variable. So purposefully names are given so that you can understand the meaning of it. So can anyone tell what is the meaning of pointer? Have you learned pointers? क्या होता है pointer? In C programming, you may have learned pointers. Anybody knows what is the meaning of pointer? Ashish, can you help? What is pointer? Ashish, yes. Okay, Shubham, just wait. Ashish, unmute yourself and tell me what is pointer. Quickly. Rutuja. See guys, this subject, if you read from the book, na, you will need lot of time to understand it. So if you attend the lectures actively, it definitely going to help. Okay. I'm calling some names and these students are not responding. Means you guys are just attending the session, but mentally you are somewhere else. Okay, Shubham, please go ahead. Tell me what is pointer.
Yes, ma'am. These are the special variables which helps us to point to other variables. Like it just holds the address of other variables.
Exactly. Perfect. So pointers are very special variables which helps you to store address of other variables. Okay. So I'm using it for same purpose here. So pointer is a variable which we have declared which will store a value again like normal variable, but वो value जो है वो address of symbol है. So look at here. A of table means address of table. So आपका टेबल वेरिएबल कहाँ डिक्लेयर हो रहा है? स्टेटमेंट नंबर 11 पे. So जो भी एड्रेस उसको अलॉट होगा, that address we are going to put here as a value of pointer variable. So when you will get the address of table variable, whenever you will load it in a main memory. जब एक्चुअली लोड करोगे तभी उसका एक्चुअल एड्रेस मिलेगा. सो एट द टाइम ऑफ लोडिंग दिस फील्ड विल बी अपडेटेड. जैसे ही आपका टेबल का एड्रेस मिल जाएगा, यू विल बी अपडेटिंग द लोकेशन 12 address you are expecting over here. Okay. Then in statement number 13, it just defines storage with a name result. Some space is reserved to store the results. Save is another space where we are going to store some results. And then address of sum. So sum is again a special variable. Look at here. It is an outside entry. So address of sum variable we are going to put here in this area. So again it is changed at the time of loading. ये जो address है ये change होगा at the time of loading. So here it linkage information is required. Okay. And then end of the program. So if you look at the variable save, pointer, asum, result. So save, result, table, these are the variable declared in same program used somewhere else. Okay. So these are addresses or these are the variable whose address depends on the starting address of your program. So John का address depend करता है. So table, pointer, result, save. These variables are dependent on your John symbol. John का address change हुआ, rest of all will be changed. Okay. And the sum, a sum is a variable whose value depends on address of subroutine sum, जो कहीं और define होगा. Again, this will need to be relocated in future. So for this sample code, if you generate translated code, normal assembler जो आपने first unit में पढ़ा है, with that logic, if you translate the code, it will look like this object code. So start will initialize your location counter to 0. So see here my LC is maintained. This is my relative address LC 0. And I'm keeping the value as it is. So entry and extern will be added on ESD card. Okay. So ST symbol will be stored 0 onwards. And see save. So save will get some address space when you translate it. So that address I have added here. Right now you may feel it is in advance, but if you look at the code, वो बाद में update हुआ है, इसलिए मैंने उसको blue color में highlight किया है. Okay. Similarly, next instruction is load, another load BALR. I'm not going to explain how the translation is done. I have already explained in our first unit. The point of interest is the address dependent locations, जो relocate and link होने वाले. Okay, so I'll just come to that first. So from 0 to 60 entire program is stored. Okay. So if you look at the statement 11, 11th statement is declaring array of 5 elements. So it starts from location 24. So the address of starting address of your table variable is 24. Okay. So that address is added here. See, pointer variable holds the address of table. So table address is 24. That we have added here. See, 24 value यहाँ पे store की गई है. So if my starting address is changed, instead of 0, it will be 100. So 24 की जगह आपको 124 लगेगा. So this field will be a relocatable field. और relocate किसके ऊपर depend कर रहा है? Starting address, that is John. Symbol John will help you to update the location number 44. Relative address 44 is updated based on address of symbol John. ओके उसको स्टार्टिंग एड्रेस 100 मिला तो आपको ये फील्ड की वैल्यू अपडेट करनी है. So from 24 to 40, your data array, table array is stored. 1, 7, 9, 10. These values are stored over here. Then 24, this field is at 44th location. Result है आपका 48 पे, save है आपका 52 पे. ASUM is stored at location 56. So now you don't know. Sum is a external symbol. Line number 3 or statement number 3 is informing. External keyword है वो. So वो other program में होगा. So जब आप assembly पे current program translate कर रहे हो, you don't know the address. That's why यहाँ पे blank या question mark आ जाएगा. Okay, just put a question mark. So this field will be updated whenever you load the program sum. जैसे sum मिला ये field आपका relocate होगा. So this field is depend on home address of sum. It's not dependent on John, it is depending on sum. Okay. So here I have added a information. The red color statement, nice 24 और ये जो question mark है, that I have maintained. Red color specifies these are the address constant whose contents will be changed whenever you load the program. जैसे आप program load करोगे, these fields are updated. ये जो values है 24 की जगह question mark की जगह क्या आना चाहिए वो आपको समझ में आएगा whenever you load it actually. Whereas blue color text is referring the value that need to be changed when your origin change, starting address changes. Okay. So see here 52 means आपका symbol save है. So save is stored at location 52. That's why I'm adding here 52. But 0 के reference में 52 है, right? If you look at the value 0 starting address है, that's why यहाँ पे 52 मिल रहा है, right? अगर मेरा starting address 100 हो जाएगा, so what will be the location? 52 रहेगा क्या वो? No, it will be 152. So ये जो field है आपकी blue color में वो change होगी if your starting location is changed. So all the blue color text will be modified when your starting location is changed. So this address 52, 44, 56, ये address किसका है? ये वाला. 56 means address of sum. 44 means pointer value. So these values are referred over here, which are dependent on the origin. Okay. So this is table code. But now time is feed them in your cards. ESD card, RLD card, external card, all those cards. Okay. So here is just a reference for you. So if you remember the ESD card, it is an external symbol dictionary. So if you remember what we have added, all the symbols coming with entry keyword, all the symbol coming with external keyword and the segment name. So entry of these three symbols will be done on your ESD card. So John, result and sum, these three entry will be made over on there on a ESD card. So see here, whenever you start scanning line by line, first आपको मिल रहा है segment name. So John is coming with the start symbol, that's why type is segment definition. I'm assigning ID as 01. Its starting address or initial value of location counter is 0. At the moment when you enter John here, its LC value is 0. So I'm keeping LC here. And the length of your entire segment is 60. If you observe your previous slide, see here, starting from 0 to 60. This is the entire length of that segment. So length of that segment is kept as 60. Fine. Second is result. Result is declared in current program, used somewhere else. So current program में उसका declaration है, right? So definitely its type is local definition. It is locally defined in your current segment. So its definition is local definition. Type is LD. So for local definition or variable, if you are not allocating ID, that's fine. Allocate किया तो भी okay है, नहीं किया तो भी okay. So you can keep it blank or you may assign some number to it, no issues. And what is the relative address of this result variable? So look at the previous slide. Result is available at the location 48. ये जो है. So this relative address, location counter value of result variable, I am keeping here as a relative location 48. And if you remember my explanation, the symbol with a type LD and ER will not have any length. So length field is blank for this result. Then third symbol is coming with extern keyword, sum. So that's the reason type of this symbol is external reference, because it is coming with pseudocode extern. And allocate, see, your first symbol is taking ID as 1. So this symbol is taking ID as 2, unique ID as 2. And for external symbol, you don't know the address. That's why address field, relocation field is blank. You don't know the length. So length field is also blank. So this is the way you can maintain the ESD card. So आप जब आपका program scan कर रहे हो, what the assembler will do? It is keeping watch on start pseudocode. If it is with label, label added on ESD card. Okay. Similarly, keep watch on extern and entry pseudocode. If you got the extern pseudocode, enter here on this ESD card. If you got entry pseudocode, enter here on this ESD card. So only these three pseudocodes, start, extern, entry, will make a entry in a ESD card. Please remember this key point. If you got extern keyword, or entry keyword, or your segment name coming with a start symbol, please bear with a name. So only these three are having ability to update your ESD card. बाकी किसी भी statement में आपको कोई interest नहीं है ESD card के लिए. Only these three records are important. So everyone clear with this example? Next thing is maintaining RLD card. So for RLD card, you have to, I'll take you again back to this example. RLD card tells you that relocation and linkage directory. So the location which you are going to update while loading, whose address depend on either external procedure or whose address need to be changed when you load the program. So look at this red color area, the location 24 and the 56. These two are the locations which you are going to update when you are load the statements. Okay, so they need to be relocated and their entry will be created on RLD card. So you have to keep watch on a statement where you are depending for the addresses on the other symbols. Okay, so 24 is the address of table variable. Okay, relative address 44. So this value will be modified if your address of table is changed. Okay, 24 ये location change हुआ तो ये field change होने वाला है. And this 24 depend on who? Origin. And origin किसके पास है? Name of the segment, that is John. Okay, so statement number 12, or you can say relative address 44, need to be updated. Value to that location need to be updated based on starting symbol. So its entry will be on RLD card. Similarly, relative address 56, whose value need to be updated whenever you will get the address of external symbol sum. So this address direct depends on sum. So these two entries, 44 and 56 relative address entries, will be created on RLD card. So see here, statement number आपको maintain करना है. So your statement number 12 and statement number 50. So see, so statement number 12, whose relative address is 44, that value need to be updated if your symbol John value is updated. So 44th location depends on the symbol John, whose ASD card number is 1. See, previous card पे जाओगे तो unique ID assign is 1. So this one I am going to add here. Okay. And the length of that symbol is 4 bytes. Now this is fixed. For all relocating loaders, all the instruction length is fixed. It is of 4 bytes. So if your starting address is 0, the value to that location were 24. ये आपको अभी तक मिला है, right? If I change it to 100, so what am I supposed to do to get the correct value here? So this base address 100 will be added in the current value 24. So 124, sorry, 124 will be a new value. So that's the reason we are adding base value of a John to this relative location to get the relocated value or updated value 124. So that's the reason flag value मैंने plus कर दिया. Okay. Similarly, 15th location, 15th instruction whose relative address is 56. And this is directly depending on the symbol sum. Sum is your external reference. Look at here. This is a external reference. Unique ID to sum we have added as 2. So use the same unique ID here. So ये आपकी linking है ESD card and RLD card की, these IDs. And the value of sum is again added in this location. Address of sum itself hai, right? So right now we can keep initial value as 0 here. Suppose sum is loaded from 500 in a main memory or 50. So this location 0 plus 50 is 50. So new value to that location will be 50 again. So that's the reason I'm keeping flag value as plus. So in this way, RLD card is helping you to adjust all the locations at the time of loading with the help of this information. And then third is your text card. So it's not difficult. Entire object code, if you look at here, entire object code is as it is added along with the location counter values. And these are your statement numbers. First field is your statement number, second field is your LC value, and third field is your object code. So if you look at here, this 52th location is referred here. This 56th location is referred here. So I'm keeping initially 0. So जैसे ही आपको some routine का address मिलेगा, you will just add that value. You'll be able to update it. In this way, our text card is maintained. And the last, your end card. So end card will be started with a address, let's say 100. Suppose your actual load address is 100 onwards. So your end card will maintain this value, and once your loading is completed, you will be jumped to the location 100. This is how this information is utilized by direct linking loader. So till now I had explained all the cards used by direct linking loader along with their formats. And this example is helping you to understand how to update the values on those cards. If you have understood this very well, then only design of direct linking loader will be understood in future. So let me know if you have any questions. For today,
Ma'am, in
this is okay. Yeah.
RLD column flag.
Yeah.
I did not understand the significance of that.
Flag is telling that relative address 44. Okay. This is your location which you have to update while loading. So value to that location क्या है आपका अभी? Let's say 24. So if my original address, this location depends on whom? The symbol John. So address of symbol John will be added in this location or subtracted in this location so that you will get correct address. So if my starting address is 0, the value is 24. Okay. So आपका starting address 0 क्यों है? This is assumption while translating the code. But actually in a main memory area, suppose this is your main memory area, at the location 100 onwards, your segment John get loaded. So instead of 0, आप start कहाँ से कर रहे हो? 100 से. So if I keep this value 24 itself, so out of segment हो जाएगा. 100 to 160 is your valid range for this program, right? 60 bytes आपका 100 onwards load कर रहे हो, so 160 तक load करोगे. So 24 is irrelevant address. You have to adjust in context of address 100. So starting address 0 था तो आपका वैल्यू 24 है. So अगर मेरा starting address 100 है, so John का जो base address है that I have to add here. 24 में वो address add करना पड़ेगा. And that's why I am keeping flag as plus. And mostly addition ही होता है. There is only absolute value subtraction. तभी symbol के flag value subtract negative आती है. Negative नहीं, subtraction आती है. By default it is addition only. So I'll take one more example where you will understand when it comes minus. This field comes minus. Otherwise 90% time it is plus only. Okay. Same way आपका 56 location अभी 0 है. स्टार्टिंग एड्रेस ऑफ सम अगर आपको 500 मिला है, सो जीरो में 500 ऐड करोगे तभी तो वहां पे 500 आएगा ना. अगर जीरो माइनस 500 किया तो माइनस 500 होगा. आपके एड्रेसेस कभी भी निगेटिव नहीं होते. देर इज नो निगेटिव मार्किंग फॉर योर एड्रेसेस, so I cannot subtract that. I have to add it only. And that's the reason I'm adding the values in this fields. Location 44 and 56. Clear the idea?
Yes, ma'am. Ma'am, but what is the use of ESD ID?
ESDI. Whenever your loader loads, this is only a information given by assembler. Direct linking loader I have not yet explained. Working of direct linking loader. So when you are going to work on direct linking loader, this ESD card and the RLD card, these two are combined. So कैसे link करोगे दोनों को? So these numbers are helping you. So if I am saying ESD card entry, sorry, RLD card entry with ESD 1. So I'll go here on ESD card with ESD ID 1, and from here I'll pick the relocation, relative locations or length if required for updations. Getting? In the same example, if you want to understand, John, your location 44 depends on symbol John. But starting address of John क्या है आपको पता है क्या? This card is not giving that information. So आप क्या करोगे? John का reference ID क्या है? 1 on a ESD card. So you will reach here and pick the field. This field, relative location field आप pick करोगे. So value क्या है? 0. जैसे actual loading होगा, instead of 0 आपको यहाँ पे suppose मिलेगा. So I'm going to fetch the value 100 from here. So both the cards are linked together. सारी information एक card में ही नहीं है. So you need to use both the cards when you actually perform the loading. So when I'll start the design of direct linking loader, you will understand the meaning of this ID, maintaining these IDs. Okay?
I did
It's just for
understand
fetching
like
the.
it is. Yes, ma'am, to combine both the tables like RLD and ESD. But we can also use symbol for that.
Yeah, you can use symbol for that, no issues. But those who have maintained accessing in index numbers were simple for them. So it's given as for IBM machine. Na? We are keeping our hypothetical machine as IBM machine. So whoever have designed, they have maintained it. And I have just given a single example. Okay. In future, these IDs are utilized. Right now, I have just given a linking information between two tables, ESD card and RLD card, right? But in future, when you start learning direct linking loader, two more tables you will learn, guest table and laser table. So they are maintaining only integer field. So symbol dependency resolved by these integer fields. तो यहाँ पे ये जो फर्दर टेबल्स क्रिएट होंगे, इनमें आपको ये आईडीज यूज करने हैं. So keep a patience till I explain the direct linking loader design, where we will create these two tables in which you are going to utilize these IDs. Because value to that index number आपके array है, लेसा is your array. So array of index जो है वो John symbol नहीं हो सकता है ना. It will be a numeric value. Array का index जो है. So this I am going to use as a array index in future. So when I'll explain design, you will come to know the significance of this ID, additional significance of these IDs. One is to link with these two cards. Second is use it as an array index in future. Any other question?
No, ma'am, thank you.
Great. So I request everyone to go through this recording one more time. I'll share one video if possible. Go through it and remember all those things, because then only we'll be able to understand the design of direct linking loader, which is again pass 1 and pass 2 based logic. So two pass direct linking loader you have to learn, and that's last point of your loader bit of this unit. So tomorrow's session, I'll need a recap of all those things. So you are requested to go through these recordings and try to understand the format of all these tables one more time. Solve this example one more time. Okay.